Welcome everybody. This is a great room to be in. I'm not going to say how full it is, but you can't see this, but it's actually quite full. There's a lot of people in here. But thank you for coming in and thank you for tuning in. I know people are watching in from their homes, and it's a bit of a shame that not everybody's here, but the show goes on. My name is Salman Iqbal, and I know this is the second to last session, so it's been a long 3 days and some challenges, and we're going to keep it light. We'll keep it light. We'll go into details. I'm going to try and keep it light, and we'll cover quite a few things. Hopefully, they will be useful to everybody. So I'm going to be talking about scaling machine learning pipelines in the cloud in a cloud agnostic way. My name is Salman Iqbal. You can find me on Twitter at Salman Iqbal. And if you have any questions, you can always ask me at any time. I am watching the Slack as well, so room 7. If you have any questions, you're at home, please type them in there. So if you have any questions at any time, just ask and I'll try to answer them. If I don't happen to answer them, I will answer it afterwards just to make sure that I answer everything. So as I said, my name is Salman Iqbal. I work as an MLOps engineer for a company called Appia. I just basically work with a lot of clients and take their workloads and put them in the cloud in the most efficient manner. And in terms of MLOps engineering, I basically look after any of the machine learning or data science workloads and take them and package them and deploy them in the cloud in an efficient manner where it scales and all the good stuff about the cloud. And I am also an instructor for Kubernetes with Learn K8. I've done training all over the world and of course remotely in the recent times. So that's me. So check out appia.io and learncase.io. I am from Cardiff in Wales. Anybody in here from Wales? Woo! We run a community called Cloud Native Wales. I'm very happy to be here. Again, my Twitter is Salman Iqbal. I do also happen to have a YouTube channel. And please forgive the cheesy thumbnails. I make some videos about Kubernetes because that's like short videos about Kubernetes. So yeah, of course, it'll be great if you can, as people say, like and subscribe. I've got more videos coming soon, but that's just something I do from time to time. Well, I thought because you've made an effort to come here, but please don't check your Wikipedia articles. I thought I'd give something away because that's probably the right thing to do because you've made an effort, you've stayed here till the end, and you've come to this session, given all the challenges. So I've got this little retro arcade racing game in my hand, right? So the question is, what's the population of Oslo? Whoever shouts the closest answer in the room, everybody is allowed to participate. They'll win this. It's an arcade game. So give me some answers. What do you think? What's the population? What was that, sorry? 90,000? 90,000? 950,000. Anything? Any guesses? 2 million? 1.2 million. Well, the actual population is 634,293 according to 2014. So that's the official statistics. That means you won this arcade game. Please keep that to yourself. A round of applause. I know you can't hear it, but it's quite loud. So here's the agenda for the talk. What we're going to be talking about is I know we were talking about pipelines, machine learning pipelines in the cloud, and so I'm going to probably just explain what the problem is. Why can't you run machine learning pipelines in the cloud quite easily? And I'll just briefly mention about containers and Kubernetes. And by the way, apologies for the people in the watching from home. You couldn't participate because I can't really post it out. So apologies for that. But maybe next time there'll be more giveaways. So we'll talk about containers, why they're important, and how they help out with running your applications in the cloud. And then we'll look at Kubernetes because that's where all the cloud agnostic stuff comes at and all at scale. And then we'll talk about QFlow. It's an open source project. Everything in here we're going to be talking about today is open source project that runs on top of Kubernetes that helps you create these pipelines in the cloud in a cloud agnostic fashion that you can scale and you can do what you want to do. So who is this talk for? This talk is for engineers. If you're interested in learning about what kind of issues data scientists and machine learning or engineers or data engineers or DevOps engineers face, you'll find this interesting. Or if you're a data scientist or a DevOps person, I think this talk is pretty much for everyone, I'd say. So what is the problem? What is the problem that nowadays data scientists and machine learning engineers face? as a data scientist or an ML engineer, we would think that you only have to deal with gathering training data from whichever source you're getting the data from, and test data, like you get a data and you split the data up into training and test data, just to, when you do the training, you figure out if my training is correct or not. So you split that data into training and test data. So you just think, oh, I'll just have to grab some data. Then, perhaps train your model. That's what you do, right? You get the data, you write your algorithm, whatever it might be, or you use one of the ones that already exists, and you train it. And you think, oh yeah, that's it. That's all I need to do. Just train a model and then and evaluate how everything works, and everything's great. And now I have a machine learning model that can detect, I don't know, some issues in X-rays, or I can detect faces of people when the camera is pointed at them, or whatever it might be, whatever the machine learning thing that we're doing. But the reality is far from that. That's not the only thing you have to worry about. I mean, when you're doing demos locally on your machine, that's probably, data science 101. That's what you do. But in reality, when you want to run stuff in production, there's a lot more than just taking that data and running it. You have to figure out where you're going to collect that data from, what APIs you're going to call, where do you have to store that data. Then you do some feature extraction. Then you have to verify the data that you have. Is that correct, or what is it? And then you do some configuration. You have to figure out the configuration of the application itself, and the code has to run somewhere. It has to run somewhere in a machine, in a virtual machine, wherever it is, because eventually we do need some resources, be it Kubernetes or not, whatever it is, we need that. But you have to create those machines. You have to provision them and set them up and all that sort of stuff. And once I have a model that's been trained, what usually people do is they serve the model. Serving the model is, hopefully you understand the term, is that once you train the model, you want other people to send their requests and use the model. So you have a model that detects what kind of plant, the photo is in, what kind of plant is in the photo. People can, if you serve the model, people can send like if you use the app that's sending a request somewhere where the request goes to the serving mechanism and returns the response back saying, oh yeah, this is a cloudberry or this is that kind of plant. You also have to worry about monitoring. If things go down or things don't work, how do I do the monitoring of all of that stuff? Kind of all of the issues that you come across when you're productionizing a system. And usually when we think about data science, we just think about the bits in the middle, right? The light brown bits in the middle. But in order to productionize, we have to worry about all the things that are around it. So you have to kind of figure out how to do actual proper development, because you have to write the logging and whatever it might be. So you have to do that. You also have to learn about how to set up infrastructure and how to operate it, how to scale up, scale down, wherever it might be. And you also need to figure out, also need to figure out how to do data science, right? So that's a lot that's on the plate of the data scientists and data engineers, because in some organizations, of course, there might be people that are, they're giving you the infrastructure, but in a lot of cases, the data scientists might just have to do that themselves, and that's a lot to put on somebody's plate. That's the problems don't stop there, right? They keep coming thick and fast. Imagine you have hundreds of models you're training. You're a company that use this data science to train these models every day, every week, depending on when the new data comes in. For example, you are in charge of these three kind of algorithms in your organization. You have a recommendation engine. I know this is a simplified example. You have an anti-spam engine and churn rate. Now, these three different kinds of models that you have. But daily you get data, and daily you want to update the data, update your model based on what's happening. So every day you might start training the data again, go to the new version, keep going to version 3, version 4. As the data keeps coming in, you have to keep retraining it just to make sure everything's up to date, right? So, and you have to do the same for the anti-spam filter, and you have to do the same for the churn rate, depending on how often the data is coming in. Sometimes it might be coming in once a month, sometimes it might be coming real time. But that's not the only problem, because you have to do that on a Monday, on a Tuesday, Wednesday, Thursday, Friday. And you know what's coming next. If you're unlucky, you probably have to do it on a Saturday and Sunday as well. So this is, a very boring and a tedious task. You have to keep doing it manually. I mean, you can automate that stuff, do some sort of manual automation, but it's a bit slower. Maybe it's a bit error prone. It's a bit boring, of course. You can't keep doing that. Maybe there's something out there. Maybe there's some frameworks out there that can help us automate some of this stuff. So I think it's a good idea to just do a quick recap on containers in Kubernetes. Have you used containers in Kubernetes? Yeah. Okay. And if you're at home, I'll just go do a quick recap on what containers in Kubernetes are, because this is the technology that helps us to use things in the cloud in a more repeatable manner. It's not just machine learning, just also applications too. So imagine you have a container, and in the container, imagine you have a runtime, right? So you've got a runtime, all it is. I'll put Python up, it could be any runtime, .NET Core, Java, virtual machine, anything. It could be any container. I'll just put Python as the runtime. And then what you do is you get all your code files, all your configuration files, and you put next to the runtime. And then any external dependencies. In this case, I'm showing TensorFlow. Imagine this was a .NET container. This could be NPM, any of the NPM dependencies or whatever it was. We basically put all the dependencies together. So everything that you need to have in order to run your application gets packaged together in what we call a container. And now we have a container, we can build it, we can run it, we can share it with others, and we can reproduce it. Whatever we produce can be reproduced anywhere else, because that artifact, you can build it once and run it anywhere, because we've standardized how we create the applications, how we create the containers, and how we create applications inside the container. We have a Docker file, which is basically a set of instructions that says this is how to run the application, pretty much like how we do it manually. And then what we do is we take that, we build a container, and we can just run it anywhere we want to run. The good thing about containers is they're quite lightweight, depending on the type of container you're using. There are some containers which are bigger in size, but usually containers are quite lightweight, and they can start up quite quickly, which is good, because if I have to scale up from 1 to 100 containers, I don't have to wait for too long. It will come up really quickly, serve all the traffic, scale down. Or if it crashes for whatever reason, because that can happen, it can start up again. And another good thing is that's less operating system overhead. In virtual machine, you have to have a guest operating system on there, guest host operating system in a virtual machine, of course. And that takes a lot of resources. But in containers, they are self-contained, and they just use the guest host operating system. Just one operating system, and I can run multiple containers inside. So basically, there's less overhead in running containers. Now, stopping and starting one container or 2 or 3 containers, it's okay. You can do that. You can do Docker run or Docker stop or Docker kill, whatever it might be. You can do that one by one. For a few containers, you can manage. But what if you have like hundreds of containers or thousands of containers? And they're not just running in one machine, they're running in multiple machines. If the container is running in one machine, like imagine you got like a front-end application that's running in a container and a back-end that's running in a different container. Maybe you're running a database in a container as well. If they're all running in the same machine, you can use the machine's networking to get them to communicate with one another. You can give it the name, so the Docker network, imagine if you're using Docker, you can get one container to talk to the other one. But otherwise, if you are in multiple machines, that doesn't work. And this is where container orchestrators come in. And Kubernetes is one of them. And all it does is basically takes your applications, and instead of treating them like multiple virtual machines, it just treats them as one instance of the machine. And think of Kubernetes as the best Tetris player ever, right? So all it does is it's going to manage and start and stop your containers for you, so we don't have to do it ourselves. So let's say I have 3 machines, and the size of the machines, the bigger, the wider the machine, the more memory or resource they have and CPU resources they have. The thinner the machine, the less resources they have. In here on your right, we've made one machine in charge. That's known as the control plane, and the rest are the worker nodes. I want to submit my application, my container, to run in the cluster. So we submit that request to the Kubernetes cluster. Kubernetes cluster receives the request, and it says, you need to run this application, the red page that will come up in a second, deploy it anywhere you like. And what Kubernetes does, it scans for where it can fit best in the nodes. And it goes in and places that in one of the nodes, and another replica of the pod, of the container, needs to be run in the cluster. And what it does, it says, well, you have one replica of this thing already running in node 1, so let me just place that on node 2. So that it makes the decision on our behalf rather than us doing it. And that's not the only thing it considers. It considers a lot of things and then places it. Basically, it tries to play Tetris really well. Hopefully you can play that game on the thing that you want today, play a bit of Tetris. And then, the more the sizes and the shapes of the boxes represent how much memory and CPU they require, and eventually it just fits it all in and everything's now working perfectly. And that's not the only thing. In a cluster, in a Kubernetes cluster, you can have multiple types of nodes. Some can have high memory, some can have low CPU, some come as GPUs. You can basically have one cluster and you can have multiple types of machines, because you might have different requirements for different applications. You might have an application, a data science or machine learning application that needs to do its modeling overnight on a GPU, so you can have it in there. And what Kubernetes can do is, depending on how you define your requirements for this workload, it can go and display, it can go and put it up. And let's say the next one in here, we say, oh, for this application, I need to be deployed in GPU. So it will go ahead and deploy it in a GPU. And we'll keep doing that same thing. I'll say, okay, for this application, I need a low priority CPU. So we'll stick that in. And it will control that. And it's good because in Kubernetes, state is persisted. If you lose anything, apart from where the state is saved, it will bring it back up. So we don't have to worry about that. Where can we run Kubernetes? You can run Kubernetes pretty much anywhere. You can run it on your personal devices, on a laptop or a Mac or whatever it might be. You can run it on premises. You can run it on in any of the cloud providers. You can run it on Edge. You can run it on Raspberry Pi. Wherever it meets the minimum requirement, you can run it there. There's also a lightweight Kubernetes called K3s that you can basically run anywhere you like. So the benefits of Kubernetes, this is the last bit, and then we'll actually jump into the pipelines. The good thing about Kubernetes is it allows you, in terms of like when we can do deployments of your new applications, it allows us to avoid downtime. And if anything crashes or fails, it'll bring it back up itself. And also, it allows us to scale. And that's quite important in terms of machine learning scaling in the cloud, because sometimes we want to scale depending on the requests that are coming in. We can scale the number of replicas are running, or add more virtual machines in our cluster to make our cluster even bigger, which is what we really care about. The best thing about Kubernetes, well, is a bit complicated. Of course, there's a lot of complexity in Kubernetes because it allows a lot of extension, is the infrastructure abstraction. So I can take an application. If I write an application that has to run on Kubernetes, that Kubernetes cluster could be running anywhere. It could be running in Azure. It could be running in AWS. It could be running on my laptop. It could be running anywhere, and I can take those same application files which I used to deploy on my laptop, and I can deploy the same resource files. I can deploy it in wherever I like, in AWS and GCP. We can't do that with virtual machines. If I create a virtual machine in Azure, the same virtual machine, Ubuntu or Windows or whatever it might be, I can't take the image and run it in AWS. That's not possible. But with Kubernetes, it gives us this abstraction, so we can, in most cases, become agnostic to the infrastructure it's running on. I know this is one of the things that people sometimes have to look at, because you might get tied down to one cloud provider. There's one more thing Kubernetes is very good at. I'm gonna quote Kelsey Hightower, who's a legend in the Kubernetes game. Kubernetes is great to build platforms on. And you can deploy applications, of course, but you can build platforms on top of Kubernetes. And this is where our talk about scaling pipelines and QFlow comes in. So let me introduce you to another actor in our presentation, QFlow. It's an open source, community-driven project, and it makes easy to deploy and manage machine learning stack on Kubernetes. If you're doing machine learning stuff, there's a lot of tools that people have to install, a lot of projects people have to install on their machine or on their infrastructure. What QFlow allows you to do is it introduces all these things in one go. So when you install QFlow, you get a lot of things, a lot of frameworks, a lot of tools that are available to you kind of straight away. And even though we're going to focus on the pipelines, I think I'll just mention some of the things and that people use and how it can help the data science and machine learning engineers. Usually, a data scientist or a machine learning engineers, they have requirements, just like you and I. Everybody has requirements, of course. They need an IDE, they need a development environment where they can quickly experiment with their code and check everything is working, and they can create like run books of some kind. So I'm sure you've heard of Jupyter and Jupyter Lab or any project like that. You need something like that where you can run some commands, where you can run some scripts in Python, some in R, whatever it might be. You can use that. And also, maybe there's an easier way to install the right version of the right framework, because framework versioning also keeps changing. And perhaps one of the things that people do really care about is pipelines. I mean, I can write code and run it on my machine or on my laptop, and that'll work okay. That's fine. I mean, I can run that, but I can't really scale it because, first of all, I need more processing power to be able to run it. If I wanted to, let's say, ingest more data, so I can't really run that on my laptop. I need to be able to create a pipeline somewhere where I can run, and I can run it locally and run in my dev environment, in my production environment, in my staging environment, everywhere I like. Also, once the model is trained, I need to be able to serve the model, so people can send a request and query it and find out if what they're checking is, if they can send a text or send an image and get a response back of what's in the image. So this is where QFlow comes in. QFlow says, okay, we know there's a lot of requirements that you have. Let's take care of all these requirements for data scientists and machine learning engineers, or anybody else who's interested in doing some of this data science stuff. So since we can, we have Kubernetes, we said we can use Kubernetes as a platform, as a place we can build our platforms. We can run Kubernetes on a local laptop or wherever it might be, wherever we're running it. What we can do is we can install QFlow on it, just like you can install anything else on. And the way you install QFlow is you get some configuration files, and there's a command line tool that allows you to install all these bits inside the Kubernetes cluster. And all that does is just run some extra containers in your cluster and create some services, just so you get these extra bits that you need to have running inside the container. And I'll show you some of that stuff in a few minutes. So once I've installed QFlow is now installed in a Kubernetes cluster, which is a set of tools that are beneficial for us. Tools that already exist, and some tools which are new, which are part of QFlow. One of them is you can create Jupyter notebooks. This is something that data scientists and people have used. Have you used Jupyter notebooks before? No? Yeah, people have used it. Excellent. So this is something people can use to really quickly develop and look at their code. So it helps us with like spawning and scaling or scaling down the notebooks. The bit that we're gonna focus on is QFlow pipelines. And this is reusable end-to-end ML workflow pipelines built to run on a Kubernetes cluster. So you can define a pipeline using most data scientists' favorite language, which is Python. So you create a pipeline using Python, but in the pipeline, each step can be written in any language. And I'll explain to you in a second. And you configure it once it's written in, so you don't have to write like YAML files. I know everything's in YAML files nowadays, but you can write actual code. And you can experiment really quickly because you can iterate over it and test it, see if it's working. If it's not working, you can throw it out and start again. And you can make components in a pipeline that are reusable, which is what we usually have, right? You say, okay, we need to have, every time we do a verification of the data, it needs to go via this set of rules. And those set of rules are standard for everybody, for every project. And if that's the case, you can make a component that's reusable. So we'll look at, I'll show you some pipelines and I'll show you some notebooks. And there's another thing that Kubernetes allows us to do is extend Kubernetes using what's known as operators. And if you don't know what operators are, you're probably aware of what operators are, but I'm just going to do a quick, brief explanation of what an operator is. Kubernetes comes with some built-in resource types. For example, how to run a container is you can run it as a pod, or you can run it as a deployment, or you can run it as a job. So there's some built-in types. So if I create a configuration file and say, oh, run me a container using this pod definition, and I submit that to Kubernetes cluster, it will spin me a pod. But what you can do is you can define your own custom type. You can say, every time I submit a request, and I say, create me a MySQL database inside a container, and you can do that. You can do that with what's known as an operator. Now, with the custom resource definition, you can define that. But once you define that definition, that's just there. The definition sits. It doesn't do anything. There's a concept in Kubernetes called operator, which is custom logic that you write that watches over this your definition that you've defined. If somebody submits a request and says, oh, I need a MySQL database, it knows what my SQL database looks like. It knows what disk it needs to attach to. It will go and create one for you. And if the database crashes for whatever reason, whatever it might be, maybe the server crashes, Kubernetes say, oh, there's supposed to be a server running. It's down, it will spin it back up. That's what the operator is. And that's what in QFlow, there's a lot of operators that are there for running things like Spark. Again, another framework that's used for big data. So there's quite a few operators in there. So let me explain you one more thing before I talk about the next bit. Imagine I have this data set. These are all, I'm sure you've seen this, it's called the fashion mnist. So this is all the fashion fashion articles, clothing articles, and the labels on it. So what's a shoe, what is this, what is that? And usually what you can do is one of the ways of us trying to predict what item you have is you can train a neural network. Neural network is based on how our brain works and how neurons communicate and how they create a pattern and trying to figure out what you're looking at. And that's what the idea behind neural networks is, and I'm sure you're already aware of that. And what we do is we take a training. In our training stage, we have an image and we have a label. So every image has a label. The top one has an ankle boot. And what we do is we train the neural network. We submit the request and say, oh, the top one is a boot. And we send a different type of boot and a different type of boot. And if I submit a shirt, it says, okay, this is a shirt. So now we've trained it. This is usually everything. Once it's trained, what we can do is then we can submit a new request that's never seen before, and it predicts it for us. It says, oh, yeah, that's an ankle boot. So that's great. So that all works fine. Now, this is just, you already know this stuff from before. This is how training of a neural network works. But while you're training the neural network, there's something called a hyperparameter, that's a value that's used to control the learning process. So we can modify those values. For example, I'll give you one example: the learning rate. Another example could be like the number of layers that you have in your neural network. So learning rate is a hyperparameter that controls how much to change the model based on the response to the estimated error you get each time the model updates get updated. It just keeps going around in circles. It says, oh, there's an error that we're not supposed to have. And then learning rate, you can increase it, you could decrease it, so it learns faster, learns slower. You can do that manually. You can update that manually if you like. But wouldn't it be great if something can do it automatically? So we don't have to go in and change the learning rate to 0.6 if you've done machine learning or data science before. You can change when you're doing the training, you can change, you do some runs and you go, oh, let me change the learning rate to 0.5, see how it does. Let me change it to 0.4, see how it does. But there's a project called Katib, and that does it automatically. So we're coming in this auto ML, auto machine learning territory now. So this project basically allows you to tune these hyperparameters automatically, and also do some early stopping. That's like if you don't want to overtrain our model, we can do some early stopping, and also try and figure out what's the best architecture for the neural network that we have. How many layers should we have? So this does it automatically, and this project is machine learning framework agnostic. It doesn't matter what it's written in. it will basically do that and will store and will update it. And one of the things in that people would like to do in data science and machine learning is make reproducible workflows, track and manage the data, the artifacts you produce. Track and manage. Like if I have, how can I label a data set that I have? Now there's a project called the metadata, and metadata could mean anything, right? So there could be information about the runs that you've had. It could be models. It could be data sets. It could be other artifacts like files or objects or images. And we can use this metadata to version everything. So we know when we ran an experiment, which part did we use and all that. So this is that metadata project. So there's some tools there that are useful. And one of the last ones is I'm going to talk about is serving. So once we have the model trained, like we had before, we can open it up to the world, right? We can say, oh, you send a request here. But imagine you open it up to the world, you might get more requests to figure out what's in the image, and you have to scale up a service or scale it down. And you can write your own web server and serve it, but how do we do the scaling? Excuse me. So this is where the serving frameworks exist in a lot of data science frameworks. And one of them, there's quite a few frameworks which you have to figure out to install, but QFlow makes it easier by using this KF serving framework. If you look at the top box, that's called KF serving. So if I start from the bottom, there's Kubernetes. Then the way QFlow works is it installs a few more frameworks. There's a few more frameworks there before it can install QFlow. There's Istio, there's Knative, and then it installs this QFlow serving, which basically I can scale up using Knative. I can scale up the serving and scale down when nobody needs it. If you're interested, just a shameless plug. If you're interested in Knative, this is a cloud native. This is a cloud native project. I'm doing like a spaces with my friend Mauricio Salaboy on Twitter Spaces on Monday. If you're interested, listen, and we just talk about what it is, how does it work with Kubernetes, and how can it save money, because that's what the point of that is. So basically, KF serving produces a custom definition. Again, is a custom type for machine learning, you can serve anything you like. And also, when you install QFlow, you get a ton of other frameworks, the machine learning frameworks that you might know, get installed. So that's QFlow. But why are we trying to run this on Kubernetes? Why? The reason why we're trying to run this on Kubernetes is Kubernetes gives us scale. So I can auto-scale things. I can scale, if my application couldn't handle the traffic, it will auto-scale it up. And if I was running out of resources and I needed more cluster, it will auto-scale that. And also, I can do a lot of logging and monitoring if it's running on Kubernetes. So, I said in the beginning, we need to do like logging and monitoring and all that sort of stuff. So this is just some of the points. And there's a concept called quotas in Kubernetes where you can define how much memory and resource something can use, or what's the max or min for it. And you can define that using Kubernetes, which is helpful. And also, RBAC. RBAC is important. I don't want everybody to be able to log in. Some services need to other services and need to talk to other services. And that's why we look at Kubernetes. So really briefly then, I'll do a quick demo as well about the QFlow pipelines. This is the pipelines in the cloud. How do we run them in the cloud? Most data science and machine learning processes start with the ETL, extract, transform, and load data. You get data somewhere. If it's unsupervised learning, this doesn't apply, of course. But if it's supervised learning, which is based on the data that you've trained on, then you have to go through this ETL process. And then we do some training based on the data, as we were saying, and using algorithms from a number of frameworks of our choice, whichever it might be. And then we analyze the result. We say, okay, what do we need to do? Do we need to change anything? And then what we do is we just predict it. Now, this is a bit of it's a pipeline here, right? So we've got a pipeline going. We need to figure out how we can deploy that, how we can create in the pipeline. There might be other things. You might be in the training, there might be multiple steps. So this is where QFlow Pipeline comes in. This is a project that's part of QFlow. And using that, you can create multi-step workflows for machine learning. And you can run anything in those steps. Now that could be written in .NET, that could be written in Java, it could be written in any language. The only thing is, in order to orchestrate those steps, you have to write the orchestration in Python, because it's aimed towards data scientists and machine learning engineers, so they can write their own pipelines, because this is about shifting left, right? Not DevOps people shouldn't write their pipelines. That's why you have to write it in Python. And once it's written, you can productionize it. And this is what the pipeline looks like. You can see it in the diagram here. So each step here, each block that you see is a container. It will take an input, give an output, and you can get these steps to rely on one another. So one can only run, so predict can only run once you've done the training and the creation of the volume, because that's where we get the data from. And then, like, you can make it as complicated as you like, if that's what you want to do. So what is the flow like? And I'm going to quickly show you the flow, just so you know. You write some code in somewhere, Visual Studio Code, where it might be. And for that code, different steps of the code, you create a Docker image. And you upload that image or container image where it might be. You can upload that in a container registry. And then what you do is you write the QFlow pipeline, the orchestration bit, to say, okay, this step's run first, this one's run second, this is the input, that's the output. And then you have to compile it. That's a step again. You compile it, because it's written in Python. You compile it, and it creates you a pipeline configuration file. And then you just upload it into QFlow, and now you have a pipeline. And you can run that pipeline whenever you want and how you want it. So I'm going to do a quick demo. We won't take too long. We'll do a quick demo. By the way, how's everybody doing? Is everybody okay? Just any questions? Okay, we're good. Cool. Sorry, I don't have anything else to give away. Yeah, I did have 2 things to give away, but what happened was I did an extra session on Monday, so I had to give it away on that. Oh, sorry, not Monday, Wednesday. I wasn't supposed to do it, but I just filled in. So if you came to that talk, there was a giveaway there, but there's only one thing. So what we got is a Kubernetes cluster, so you can demo. I'm doing it on my local machine because it doesn't cost me money, but you can have a Kubernetes cluster anywhere you like. But the best thing if you want to get started is to do it on your machine. And on there, you can install QFlow. I'll share the links later on in Slack once we're done, so you can do the demo yourself. And I'll show you some pipelines. We can upload it or whatever. But we'll just keep it short. But what I'm using is what's called MiniKF. Like, if you need to run Kubernetes locally, you use MiniCube. And this is similar to that. It runs a virtual machine on your machines using Vagrant and spins everything up. So I'm going to do a quick technology magic and mirror my display. Yeah, magic works. Now if I go to my browser, once everything's installed, we'll go here. It gives you a login screen, and you can connect that login screen to any OIDC provider, so you can log in using Microsoft Azure login or anything like that. That's why it's beneficial, RBAC stuff that we're talking about. When you log in, this is what it looks like. Everything looks like this. This is the dashboard. We talked about Cathib earlier on, artifact stores, that's for metadata, volumes, and all that sort of stuff. And then I can have a look at, if I wanted to create a notebook, I can go and create a notebook. I can assign it to users, and they can open a notebook. I'm just going to connect to one. Hopefully it'll open up. And this is what a Jupyter Lab notebook looks like. Again, you don't have to use this notebook, but it's there if you wanted to manage it inside one place. This is where it is, and you can open a console. You can write whatever you like and all that sort of stuff. So there's a notebook that people tend to use and connect it. You can run it on a GPU. You can run it on a CPU. I'm not gonna try and add a new one, but you can. It's there. People can log in, and also you can do the RBAC. So they can only see their own notebook, and they don't see everybody else's notebook and all that sort of stuff. But the thing that we're going to focus on is the pipelines. This is the bit that we really care about, the pipelines bit. And the way pipelines work is, let me show you an example. We'll use, we'll go in here. So, it's going to be a quick one. It won't take too long. Imagine, actually, let's go in here. If you've never written Python, it's actually not much different to any other language. It's kind of pretty much similar. This is using the QFlow package, the QFlow DSL, domain-specific language. The bit that we really care about is the steps, right? So the steps, which we are. And then we define steps using this function called the echo op. We just called it a function. And then this is the thing, the DSL creates this thing called the container op. And in there we say, what container we want to run. So that's our pipeline. We're saying, oh, I want to run like an extraction container. And in here we define, this is the container. This is just running bash. It's nothing special. It's just running bash. You can pass arguments. You can do what you like. And this one is an argument here. It says echo hello world. And we can, all it will do is just when you submit echo hello world to bash, it will just print that out. It won't do anything special. And then if we come down here and we just say that I create the pipeline, this is just defining the pipeline. And all we're doing is just calling that task. We're not really doing anything else. And then the last bit is about compiling this. And when I compile it, so when I run Python, this is how we do the Python stuff, right? So when I run Python, let me just do Control C. So if I can go in examples where it is, if I go in base, pipelines, and if we go to samples, core, this is just everything in here. So, in here we got all different kinds of examples. So we're hello world. I'm going to delete that file for now. No, delete, not cut. Delete. We're doing okay for time. What I can do is, actually I need to copy the path just to make sure, I'm in the right place. So if I go in here, am I already in? No. So I'm in there, and that's my file. All I need to do is I can just do Python and run the file, hello world.py. And this will create me a YAML file. And this is the YAML file you can use to upload that eventually pops up. This is our workflow. It uses Argo in the background. That's another project. And I can take that pipeline and I can upload it. So this YAML file I can take and I can go in my pipelines and I can upload the pipeline. And just so happens that I've got one already. And I'm going to click on that. And all this does is creates an output. That's a really simple example. There's nothing to it. But let me show you another example. So if I jump back to where I was, I can do this as well. So I've got 2 steps in here, but you can do parallel. I mean, you can see I've got multiple containers happening, and then what I tell them is, okay, run this and run after that. So and then I do this compiler bit. Basically, all I'm saying is what relies on what. And if I just can go in the pipelines, I'm just going to jump back again. I'm not going to go too much in detail. So if I click on this pipeline, all this does is comes one after the other. All we're doing is passing between the images. Is that okay? Is it clear? You can basically get them to rely on one another. You can go even more complicated if you wanted to. You can go. Let me just go home. Oh no, I'm going to pipelines. You can go. You can say this is the Titanic machine learning example that you've probably played around if you have, which is we have the data set of what happened on the Titanic. So depending on you can pass this is predicting who survived the crash, basically the disaster. And if you can see this, I know you can't, it's not fitting in, but you can see you can make this thing super complex, right? So you can get these things to rely on one another, and you can run this pipeline today or tomorrow, or you can run it whenever you like. You can put it on a schedule. It'll run whenever the schedule kicks in, and it'll run that. Now I'm not gonna kick them off right now, but I can go into the one that I did before, and you can see all the bits in here. You can create data processing. I can go in, open it, and I can open the logs. Okay, I'm not printing how much in that log. I'm not sure why that's not coming in, but all these steps in here are containers. All of these steps are containers. And they run as pods inside the Kubernetes cluster. All these steps are running as pods inside the Kubernetes cluster. So the more pipelines you run, the more containers will be created. That's what it does. Any questions on that? Is everything clear? Basically, you can create these pipelines using this thing. Now, I'm going to just switch back real quick, just so we can start wrapping up and talking about other stuff. If I can find my slides. Yeah, they're right there. But you might say, oh, that's all manual though. How does it fit into my CI/CD pipeline? How do I fit that in? There is an SDK, so QFlow Pipeline SDK. It's got a lot of things in here, exactly what we've done manually. You can compile the pipeline, you can upload the pipeline, you can you can modify, you can run it on a schedule, everything. So there is an SDK that we can use. So in your pipeline, you can plug in this SDK. You can connect it to wherever your Kubernetes cluster is. Give it the credentials, and you'll be able to basically run whatever you want to run on there. Now, but you might say, oh, in Kubernetes, I want to run some stuff on a GPU. But in the pipeline, not everything I want to run on the GPU. Just some bits. The training bit I want to run on GPU, but apart from that, nothing else I want to run on a GPU. Well, we're in luck because in Kubernetes, every node can have a label, which is just a key value pair. And you can tell in Kubernetes, you can say in Kubernetes, oh, I have this container that I want to run on that specific node that has this label. And it will go and deploy it on there. And that's what QFlow uses. So this is, again, this is an example of a snippet of a code, which is one step in that container, in that pipeline, which is that one little block, the block. You see the second to last line. It says add node selector constraint role GPU worker. So that's the label GPU, worker. That's the key value label. And add node selector constraint. All it does is every time it just runs, it will go in and it'll just run on the GPU, depending on what your pipeline is. So you can attach that, and you can basically run it on a GPU, run it on a TPU, run it on a specific machine, and that's why it uses underlying Kubernetes technology to features to run it where it wants to run. So it is a long process, though. Sometimes the data scientists might just want to experiment. They don't want to keep downloading files, uploading files. That's terrible, right? What they want to do is just write some code, maybe tag your notebook cells, and run the pipeline with a click of a button. Because you're experimenting. You're not productionizing anything yet. And again, QFlow has this project called Kale that helps you do that. What it does is you have a notebook like we had before. I don't know if you can see it properly. This is just like a little notebook with the steps that we were seeing before. We've got a normal pipeline, but there's an extension that you can have in QFlow that allows you to, as you can see, you can enable it, and you can see there's an imports part, in there, the imports part. That's the label. We can attach a label to each block in there, and then you can get each block to kind of like what we did. Instead of doing it in Python, you can do it in here and say, okay, this block relies on that step and this step, and then you can submit from the notebook directly to the Kubernetes cluster. It will just basically create your pipeline, so you don't have to download it, run it, whatever it is. And so those are the pipelines. But we were talking about we wanted to scale the pipelines in the cloud. So how do we actually scale them? And I said that each pipeline runs as a pod inside the Kubernetes cluster. So the more people submit more pipelines, more pods will be running in your Kubernetes cluster. So the first pipeline only has, let's say, just one step. So one pod is running, and somebody comes in and runs another one runs, and then somebody else runs, and then another one runs. And there comes a point where Kubernetes can still handle your pipelines, and everything's fine, everything's great. I mean, you've done CI/CD. Sometimes when it's busy, you can't submit anything until the previous job finishes because of the licensing or whatever it might be. So this is where in Kubernetes, we can use a Kubernetes cluster autoscaler. So if you're in the cloud, you can use cluster autoscaling. If you run out of resources, Kubernetes will automatically add more machines for you. It will say, okay, you're out of machines, so let's just add 2 more machines. Because you have some tasks that are pending. You have some steps which are pending. If you have an autoscaler configured, you can base it on if my machines are 90% full, or if I have workloads that are pending and they're not running in the cluster, spin up the resources, and it spins more resources up, and you can run the jobs. You can run the pipelines. This is great, right? Because nobody has to wait around to do stuff. But when nobody's using anything, then Kubernetes can say, all right, cool, we can scale it back down. It's an autoscaler. Goes up and down in a different for the cloud providers. It works well for the cloud providers. Different cloud providers have different things. Just a final thought, some considerations before we finish up, before we let you go, is that it is all this stuff that I showed you in terms of infrastructure management and platform management. It is a bit complex because there's a lot of technologies that we've talked about. There's Docker, there's Kubernetes, there's Service Mesh, there's Knative. There are a lot of components in there. And all these components have different release cycles. And some things might not be compatible with other things, different versioning. So you have to kind of keep an eye on things and update them and You need to have knowledge of like updating all of these things and running them and maintaining them. So it is a bit complex. And in terms of troubleshooting, when things go wrong, you need to know a lot of stuff in order to do it. So it's a bit tricky. So the way to go around it is to install some components. Don't install everything. If you just want notebooks, you can install just the notebook stuff. If you just want pipelines, you can install just the pipeline stuff. So you don't end up with installing a lot of tools. But it does install a lot of stuff. But if you are scaling, if you are trying to run at scale, this is something that works quite well because there's one place where people can go and get their notebooks. So if you think about, in Azure, you have the ML lab, I think it's called the ML lab, and AWS is the SageMaker stuff. So it's kind of similar to that, but this is cloud provider agnostic. So you can run all this stuff without using any of the cloud providers. Just going to briefly mention, people play Dota here? Anybody plays Dota? Yeah, we got some Dota fans in here. So it's too hard for me, so I can't really play Dota. But this is Dota 2. OpenAI I'm sure you've heard of OpenAI. They've done a lot of work in the AI field. And OpenAI, they've got this OpenAI 5, which they trained their model using I can't remember now 10,000 years of gaming to learn itself and play Dota, because Dota is a very hard game. But they were able to train the model so it became like expert level performance in order to beat like humans. That's what they did. But in order to do that, they needed a lot of resources to train. So they use clusters with like 2,500 nodes. That's a lot of nodes they're running in, and they have to scale up and scale down whatever needed. And this thing runs on Kubernetes. And there's also other use cases as well. Again, Kubernetes is used in CERN to run a lot of projects because we can scale out and scale back down. QFlow is used in Shell as well. They use it for their data science and machine learning work. So there are use cases out there for this. They're increasing day by day in terms of like data science and machine learning, because it's quite new. It's quite new running Kubernetes, machine learning, data science stuff on Kubernetes. So a quick summary. We looked at how containers allow us to run package things, and then Kubernetes allows us to manage to scale up and scale down our containers. And it is platform agnostic. So the Kubernetes is platform agnostic, and I can run this on any cloud provider, or I can run it locally, and where I can run it on my machine and where it might be. Then we talked about QFlow, and QFlow is a project that allows us to write pipelines we can run, and we saw how not just the pipelines, there's some other things as well. There's some other tools that we can use in there. And last but not least, we saw pipelines and how we can scale them for the teams and how they all work. There's some references here. So there's qflow.org. MiniKF, if you want to give it a go. There's Kubernetes.io, and a couple of the websites, Appvia, should say Appvia.io, not Appvi, and LearnKate. So we got some like blogs you can check out on Kubernetes if you're interested. Definitely, if you want to have a play with Kubeflow, have a look at MiniKF. It's from a company called Richter. Allows you to set things up very nicely. And before I finish, I'd just like to say thanks to all of you who've come in and tuned in. Really appreciate that. It was great meeting all the people here in person, and I know there were some challenges, and thanks to all the organizers and all the volunteers and everybody and who helped us out here. And I definitely had a great time. I'm sure you had too. If you have any questions, you can put it on Slack, or you can message me on. Or actually, you can message me on Twitter if you don't catch me. And that's my details there. Salman Iqbal, same on Twitter and YouTube. I just want to thank you all. If you have any questions, perhaps come down afterwards. Otherwise, have a great rest of the conference. There's only one session left. All right, thank you.